Hello everyone, we're on page 325, lesson number 6. It's a continuation of lesson number 7, where we learned to factor polynomial expressions that were higher than quadratics, degree 2. But we were looking at things like this, where the leading coefficient here is 1, all right? And so we only had to look at factors of the constant term at the end. However, in this lesson, we're going to look at things where the leading coefficient is not 1, 15 in this case, so things get a little trickier. So if you factor this quadratic, you get these two things, 3x minus 2 and 5x minus 8. If you look at the constant term, 16, and the constant term in each factor, 2 times 8 is equal to 16, which we kind of knew because in previous ones we only had to worry about that. But if you look at the leading coefficients of each term and the leading coefficient of the polynomial, 3 times 5, that's 5, is equal to 15. Now, don't worry about that right now, we'll come to a conclusion in a bit. We scroll down to something slightly more complicated, so cubic, leading coefficient of 10, constant term of 231. These are the factors of this polynomial. If you factored it all out, you would get this. The zeros of this, essentially what makes each bracket 0. So this first one, 3 over 2, the second one, 7 over 5, and the last one is negative 11. Just for continuity, I'm going to say negative 11 over 1. Obviously, that doesn't change anything. What do you notice about the constant term in the polynomial, so 231, and the constant terms of the factors, 3, 7, and 11? Well, if you go 3 times 7 times 11, guess what that equals? 231. And if you look at the leading coefficient and the leading coefficients in the factors 2, 5, and 1, obviously 2 times 5 times 1 is 10. So this leads to what's called the rational zero theorem, which is the whole point of this page. Now I'm not going to test you on what the rational theorem says, but you need to remember that when you're looking for possible factors of a polynomial, it's the factors of the constant term, right? Term at the end of the polynomial, divided by the factors of the leading coefficient, all the factors of this. Okay? That is the key. You must remember this. This is the starting point for everything in every question we're going to do from now on. So, a standard question. Now they've already done part of this for us, which I don't love, but here's our polynomial. 5x cubed minus 51x squared plus 55x minus 9. So, first thing you do is look for all the factors of the constant term, which are plus minus 1, plus minus 3, plus minus 9. And you don't have, I know there's only one 3 there, because obviously there'd be another 3, because 3 times 3 is 9, but you don't have to list both of them if it's the same number. The factors of the leading coefficient, which is 5, are 1 and 5. And then the rational zero theorem, or what we just, this thing up here says, factors of the constant term divided by factors of the leading coefficient. P over Q, essentially. Okay. So then to get the potential zeros, you take each term in the numerator and divide it by each term in the denominator. So you go 1 divided by 1 will give you 1. 1 divided by 5 will give you 1/5. Remember, everything's plus minus. 3 divided by 1 gives you 3. 3 divided by 5 gives you 3/5. 9 over 1 gives you 9. 9 over 5 gives you 9/5. Those are your potential zeros. All right. If we're going to say the potential factors, and they want everything written as ax minus b, then that is going to look like this. You write this as x plus minus 1 is one factor, x plus minus 3 is another factor, x plus minus 9, and then when you write x plus minus a fifth, they want everything like this. I don't want any fractions. That's what this means. Everything must be an integer. So this becomes 5x. And so the 3/5 one, x plus minus 3 over 5, actually becomes 5x plus minus 3. And the final one, x plus minus 9 over 5, becomes 5x plus minus 9. And these guys here. Those are all your factors, the ones that are in squares. All right. Show that x minus 1 is a 0. Show that x minus 1 is a 0 of the polynomial and hence determine all zeros. What that sentence really means is factor the polynomial. And they've told us that x equal to 1 is a 0. If x is equal to 1, that means we're looking at x minus 1. What's our potential factor? So we do synthetic division. We go, okay. We go 1 on the side here. We look at our polynomial. 3, 2, 1. X is 0, so we don't have to add any placeholders. Put our coefficients down. Drop down the 5. 1 times 5 is 5. Negative 51 plus 5 is 45. 1 times 45. That's 46. Wow. I'm good. And it's negative 46. Sorry. 1 times negative 46 is negative 46. 55 and negative 46 is 9. 1 times 9 is 9. And the other is 0, which is what we wanted. That means that x minus 1 is a factor. So again, we write everything as dq plus r. Remember our quotient. We went from cubic. So this is now 5x squared minus 46x plus 9. So we get divisor, which is x minus 1 times 5x squared minus 46 plus 9. This is a quadratic. Now, everybody's going to factor differently. For a quadratic, I don't care which method you use. I use called the magic number, I think people call it. You multiply the first term and the last term, and I get 45. And you go, okay, well, multiplies to 45, and it adds to this middle term here. So, negative 45 and negative 1. So I rewrite the middle term as 5x squared stays the same, minus 45x minus x plus 9. So the middle term has been rewritten as negative 45x minus x, which would give you negative 46x. And then I bracket the first two. I can take out a 5x. So it's x minus 9. This bit here, I can take out a negative 1. You get x minus 9. You are doing it right if these brackets match. I can pull out an x minus 9. 5x minus 1. And then this x minus 1 drops down to go with it. And there is your factored form. The polynomial equals that. If you multiplied that out, you would get this up here. All right. So solving the equation, when they say solve the equation, when it equals 0, they're essentially saying find the zero. I.e., what makes each bracket 0? So 1, 9, for this guy, it's 1/5. There you go. All right, we're not going to do this, the whole thing. What we're just going to find is possible zeros. So remember, it's P over Q. So what are the potential zeros, or potential factors of 3? Plus minus 1, plus minus 3, divided by potential factor, or the factors of 2, minus 1, plus minus 2. So the potential zeros will be 1 over 1, plus minus 1, 1 over half, plus minus a half, 3 over 1, plus minus 3, 3 over 2, like that. Those are the potential zeros. If I ask for the potential factors, the possible factors, that's the brackets. So it's x plus minus 1, x plus minus 3. And for this one, you're going to write x plus minus a half, which becomes 2x plus minus 1. And x plus minus 3 halves becomes 2x plus minus 3. So those two and those two are your potential factors. Okay, so quick review. Basically, list out the potential factors of the constant term, divide them over the potential factors of the leading coefficient. Then, once you have all the factors, you test one. I will narrow it down for you. You know something is a factor when the remainder equals 0. Once you have that, you do your division. Well, to do the division, you usually get there. Then you'll end up with another thing, with another polynomial. You always write it as dq plus r. And if this is a quadratic, you just factor. If it is a cubic, then you would have to do it again. Use synthetic division, get the remainder of 0, and keep going, just like we did in the last lesson. All right. And again, I will narrow stuff down for you. You might have to test, but I will narrow it down to 2 or 3, so you don't have to test all of these. Or in this case, you wouldn't have to test all of these ones to find out which one works. I will narrow things down 2 or 3, like I'm going to do in the questions right now. So your questions are number 1, number 2, and to factor it, you're going to use the factor x plus 2. Number 4, you're going to use the factors 3x plus 1. And then you're going to have to do it twice. So the second time, you use x minus 1. 5a, number 6, and 7a. 5a and 7a, you're just listing the potential factors. All right. That was a really short lesson. I think that'll be it for this week. I will post another video that kind of summarizes what we've done so far in this unit. And then next week, we will finish off this unit, and I'll give you your first unit assignment. All right. Good luck, everybody. Thanks.